Hello students, so let us try to learn about sorting. So in this session we are going to learn three different types of sorting. We have selection sort, insertion sort and bubble sort. So the objective of the sorting techniques is to arrange all the elements in either ascending order or in descending order. So in order to understand selection sort, we are taking this particular example. We have 9, 7, 2, 35, 21 and 4. We have these elements with us and we want to sort them in ascending order. Okay, so we have 9, 7, 2, 35, 21 and 4. So in the beginning what we have to do is we have to find the minimum out of all the elements available and compare it with the first element. That would be the first step. So if we find the minimum value out of these elements, we find 2, right? Because 9, 7, 2, 35, 21, 4, if we compare all of them, we will find that 2 is the minimum value. So we are going to compare the first element with the minimum value that we have obtained. Okay, now if this new minimum that we have found out is lesser than this first element, we are going to swap the two elements. So in our case we have found 2, so we are going to swap 9 and 2. Okay, so as a general rule, what we have to do is we have to find the minimum value out of the blue box that we see, and we have to compare it with the first element. If the new minimum is lesser than 9, then we are going to swap that element with 9. And if the minimum value is equal to 9, that is we don't have any other element which is lesser than 9, then we are not going to swap at all. Okay, here we try to basically try to approach it according to the problem we have. We find the minimum to be 2, yes, because 9, 7, 2, 35, 21, 4, the minimum value is going to be 2. So we keep it in a variable, say m, so m is equal to 2. Now we are going to compare 9 and m. So if this m, okay, is lesser than 9, then we are going to swap the elements. Yes, in our case m is lesser than 9 because m is 2 as we have found out here. So since 2 is less than 9, we are going to swap the elements. Okay, so 2 will go to the place of 9 and 9 will go to the place of 2. Here you can see we have found the output of the first step that we have done. In this case 2 has come to the place of 9 and 9 has gone to the place of 2. Okay, so they have been swapped. Alright, so now what we have obtained in this particular step is 2 has found its right place. Of course, since 2 is the most minimum value out of all the elements in the array, 2 must come in the beginning, isn't it? And yes, accordingly we have found 2's right place. So 2 must come in the beginning and 2 has come to the beginning of this particular arrangement. Okay, so we need not consider 2 anymore. We have now reduced the blue box. Now we only have to have concern of 7, 9, 35, 21 and 4. Okay, so same thing will be repeated here. We are going to keep 7 in its place and then we are going to find the minimum value in this blue box. And accordingly, what is the minimum value we have out of all these elements? Of course we have 4, right? Now we have to compare 4 and 7. Okay, so 4 is this m here in this particular step. So since 4 is lesser than 7, of course they will be swapped. So 4 will go to the place of 7 and 7 will go to the place of 4. Okay, so once it is done, the new arrangement that we have is 2, 4, 9, 35, 21 and 7. So accordingly we can see that 2 and 4 are in the right place because 2 was the least valued element and then 4 is the second least valued element, right? So we have 2 then 4. Alright, so this green box shows that these elements have found their correct place. Okay, so we only have to consider rest of the elements. So accordingly, so here you can see we are now shrinking the blue box. Now the elements that we have are 9, 35, 21 and 7. So again we have to take 9 in its own place and then find the minimum value out of all the elements, 9, 35, 21 and 7. Of course 7 is the minimum value out of these 4 elements. So since 7 is lesser than 9, we are going to swap 7 and 9. So 7 will go to the place of 9 and 9 will go to the place of 7. And accordingly we find these 3 elements in their correct place. So we have 2, 4 and 7, they are in the right place, so we indicate it with a green box, and the rest of the elements are yet to be arranged. So we have 35, 21 and 9. So again we shrink the blue box and we keep concern of 35, 21 and 9. We keep 35 in its own place and find the minimum value out of the 3 elements. Of course 9 is the minimum value, so we compare 35 and 9. Since 9 is lesser than 35, 9 will go to the place of 35 and 35 will go to the place of 9. So we have 2, 4, 7 and 9 in their correct places, and the only elements that are yet to be put to the right place are 21 and 35. So now this is the blue box we have. The elements we have are 21 and 35. So 21 is kept in its own place, and then we try to find the minimum value out of the elements. So 21 and 35, the minimum value itself is 21, so we don't find a new element which is lesser than the 21, so we don't even need to compare, we just keep 21 in its own place. Okay, so 21 remains in its own place because we fail to find a value which is lesser than 21. So as we said, we swap only when the new minimum is lesser than the current element which is kept in this green circle. Okay, so since we did not find any element lesser than 21, so we keep 21 in its own place. So what are the elements which are in the right place now? We have 2, 4, 7, 9 and 21. They are in the correct place. Now the interesting thing is that 35 automatically comes to its own correct place because that's the only element left out. Since if we consider n elements, then n minus 1 elements are already in the right place, so of course definitely the nth element is also going to be in its right place. So we need not do this again. Okay, we need not have a blue box having a single element. It is like comparing with itself and it is not required at all, right? So here in this particular step we are assured that the elements are sorted. So we had 6 elements, and so 5 steps gave the output. So what are the 5 steps we had? We had 1, 2, 3, 4, 5. These are okay. So we had 1, then 2, then 3, and then 4 and 5. So these are the 5 steps that we did in order to arrange all the elements in their correct place. Okay, in order to have ascending order. How many elements were there? There were 6 elements, and steps required were 5. So that means if we had n elements, then we basically did n minus 1 steps to find the output. Okay, so this is all about selection sort. You just need to remember that you have to find the minimum value of a particular you can say set of elements, and we have to keep on shrinking that particular set in order to find the next minimum value. Okay, so then we move to the next sorting algorithm, which is called insertion sort, and it has to be approached in a different way. Okay, so we take the same example that we took in case of selection sort. We have 9, 7 to 35, 21 and 4. Okay, so now the things have to be approached in a different way. Now here, instead of keeping all the elements, we are only going to have concern of say first 2 elements. Okay, we have 9 and 7. All right, so initially it is an unsorted array. So if you consider this 9 and 7, if you consider the first blue box, here we said the see that the elements may not be in correct order. It may not be sorted, and in our example I have deliberately kept it unsorted. So we have 9 and 7, so they are not sorted. They are neither in ascending order nor in descending order. So we have 9 and 7. So initially it is an unsorted array, of course. Then take the new element and place it in the right place to make the array sorted. So what we have to do is we have to consider this blue box, and then we have to consider the last element. So the last element in this case is 7. So what we need to do is we have to bring 7 to its correct place. Okay, so 7 has to come before 9. So 9 has to be shifted to the right hand side so that a space is created for 7, and then 7 will come to the place of 9. So here you can see what has been done. Now 7 and 9 are in order. So what we did is we shifted 9 to the right so that a space can be created for 7, and then 7 was put in the place of 9. So we have 7 and 9. Okay, so we have 2, 35, 21 and 4. These elements are yet to be sorted. 7 and 9 are already in order. Okay, so now we have to include a new member in the blue box. So earlier we had this 9 and 7, then we sorted them, so we have 7 and 9. Then this new element has been introduced, which is 2. Now we have to put 2 in the correct place in this blue box. So here you can see that 2 is the most least valued element, right? So it must come to the first place. So what we need to do is we need to shift 9 to the right hand side, we need to shift 7 to the right hand side, and then put 2 in the place of 7. So here you can see 9 has been shifted, 7 has been shifted, and 2 has been placed to the correct place. Now if you consider this green box, then we have all the elements arranged. So the elements that are left out are 35, 21 and 4. Okay, so now we introduce the next element 35. Now 35 has to be now considered, and it has to be put in the right place in this blue box. Luckily we don't need to make any shifts here, or we don't need to move any elements here, because 35 is automatically in its current place in order to keep things arranged properly. Okay, so 35 need not be moved because everything is in order in the first place itself. So 2, 7, 9, 35, they are all in the ascending order, so we need not shift any elements, and we can directly say that yes, 2, 7, 9, 35 are in the correct ascending order. Okay, so now we introduce the next element, which is 21. Now we have to find out where 21 fits. So here we can see we will again have to see that 35, 9, so it must come in between 9 and 35. So 35 has to be shifted to the right hand side so that 21 can be put between 95 and 9 and 35. Okay, how these comparisons will be done? It is very simple. If this element is greater than the new element that is in the green circle, then you shift to the right hand side. Okay, so 35 is greater than 21, so 31 will be shifted to the right hand side so that the space is created. Again 9 will be compared with 21, but since 9 is lesser than 21, you need not shift 9. 9 will be in its own place, and automatically a space will be created between 9 and 35, and then 21 can be put inside. Okay, you might be wondering like how basically in terms of computing, how will we do this, right? In a programming language, how will we do this? It's simple. You make a shift only when the element is greater than the current element we are introducing to the blue box. Okay, since 21 is newly added, so 35 will be compared with 21. Since 35 is greater, shifted to the right hand side, a space is created in the place of 35, and then you can put 21 there. Okay, so now we introduce 4. So 4 has been introduced in this particular blue box. So where 4 will be put? So 35 is greater than 4, so 35 is shifted. 21 is greater than 4, 21 is shifted. 9 is greater than 4, 9 is shifted. 7 is greater than 4, 7 is shifted. However, 2 is not greater than 4, so 2 will be in its own place, and a space will be created here, and that in this particular space 4 can be easily placed. So here you can see after shifting all these 4 values, a space was created in this place and 4 has been placed here. So we have 2, 4, 7, 9, 21 and 35, and here we can see that all the elements are sorted. So how many elements did we consider here? We considered 6 elements. So we had 6 elements, and the number of steps that were required in order to have things arranged was we had 1, then 2, 3, 4, 5. Same, right? If we have n elements, then n minus 1 steps are required in order to get things sorted. All right. So but yes, of course it is different from selection sort. Here you can see the first element, or rather first 2 elements that were arranged were 2 and 4, but here you can see the first 2 elements that are arranged are 7 and 9. So of course in selection sort took a different path to sort elements, and insertion sort has taken a different path to sort the elements. Fine. So after these 2 very important sorting techniques, we come to the third one, which is bubble sort. Okay, so in bubble sort what happens is it takes a very different approach compared to the earlier 2. Here we again take the same set of elements or collection of elements. We have 9, 7, 2, 35, 21 and 4. Okay, what we have to do here is we have to create a box where only 2 elements can be put. Okay, so here we have a box where only 2 elements can be put. In earlier cases we saw that a box kept on increasing, or the box kept on shrinking, right? But in this case we are going to keep a fixed box, and in this box only 2 elements can be put, and only 2 neighboring elements can be put. Okay, so here we see that in the first step we have 9 and 7. So consider 9 to be A and 7 to be B. If A is less than B, then don't swap. That is, if they are already in order, then you don't need to swap. But if A is greater than B, that is the first element is greater than the second element, then you have to swap. Okay, here I would like to mention that in all these algorithms and all these examples that I've shown you, we have always considered to make things or make elements get arranged in the ascending order. Okay, so if we do say descending order, then the logic will be reverse of what we are doing now. Okay, so here again we want to do the ascending order. So we have 9 given to A and 7 given to B, and if A is less than B, then don't swap, otherwise swap it. Alright, so we have 9 and 7, so yes, 9 is greater than 7, so we have to swap, so we swap it and make it 7, 9. So automatically we see that this green box have elements arranged. Fine. Now what we do is we shift the box by 1 element. So it was in the first 2 elements, now the box will go to the second element and the third element. Okay, the current second and third element. So this current second and third elements are 9 and 2, so we have 9 and 2 here. Apply the same technique. If 9 is greater than 2, then 9 has to go to the second place. So here you can see we have swapped it. Now things are arranged. 2 and 9 is arranged in the ascending order. Again, shift the blue box by 1 place. So we have 9 and 35. So here you can see we now take 9 and 35. So here we have 9 and 35. So here we compare it, but since 9 is anyways lesser than 35, we don't need to swap anything. We just keep the elements the same way as it was, and we shift the blue box by 1 place. So now we go to the next 2 elements, that is 35 and 21. Okay, so here again we compare. Since 35 is greater than 21, 35 will go to the right hand side and 21 will come to the left hand side. So we swap it. Again this blue box will be shifted. So we have 35 and 4. Again 35 is greater than 4, so 35 will be shifted and 4 is also shifted. Okay, it's like it's a swap that we have done. Okay, so after doing all these things, this is one single round that has been completed. So this blue box started with the first 2 elements and ended with the last 2 elements, and finally what we see is that the highest value has come to its correct place. Okay, so see, after doing all these things, after doing all this computation, we found that the last element that we have is in the correct place. So 35 is in the correct place. However, but in other case 7 to 9, 21 and 4, they are still not arranged at all. Okay, so we have to do something more. Now what we have to do is basically we have to do the same thing again. We have to repeat the same things so that the next highest value comes to the next place. Okay, so in the second round we need not consider 35 anymore, because in the first round that we have done, we know that according to the algorithm the highest value will come to its right place. So in the second round that we will do, we will only consider 7 to 9, 21 and 4. Okay, and the blue box will be created for 7 2. It will be shifted one by one until the last 2 elements are reached. Again we will go for the third round, where only 7 to I won't say 7 to 9, 21, because you don't know which new elements will be there in these positions. But what I mean to say is, in the third round these 4 elements will be considered. In the fourth round these 3 elements will be considered. Okay, and so on. Alright, in the fifth round these 2 elements will be considered, and so on. Alright, and finally we will have all the elements arranged. So this first round that we have done, the first computation set of computation that we have done is known as pass 1. Okay, so this is the first pass that we have obtained, or what we have done in order to reach or get 35. Okay, so similarly second round is known as pass 2 and so on. Okay, so here we see that after pass 1 the largest value is in the correct place. So 35 is in the correct place, which is pass 1. Similarly we have to do pass 2, pass 3, pass 4, pass 5 and so on, in order for 21 to come to its right place, then 9 to come to its right place, then 7 to come to its right place, and then 4 and 2 to come to its right place. Okay, why? Because 35 was the highest, so pass 1 was able to bring 35 to its current place. Then 21 is the second highest, so pass 2 will be able to bring 21 to its correct place. Then pass 3 is the will be able to bring the third largest element to its correct place, and so on. Finally, in the last pass we will consider 2 elements, that is the first place and the second place. Okay, so that 4 comes to its own place and 2 comes to its own place. We did not go for a pass having a single element, because there will be no comparisons, and moreover in a in a blue box you have to store 2 elements, right? So we will not go for pass 6. Okay, what I mean to say is for pass 5 actually 4 will come to its right place, but as 4 comes to its right place, 2 automatically comes to its right place, right? So we need not go for pass 6 anymore. Okay, by doing 5 rounds we will get all the elements arranged in the ascending order. Okay, so this is what about bubble sort. I would appreciate if students go for the other passes in order to see the result. Okay, and in their result, if they find all the elements in the ascending order, then they can get convinced that they have understood the approach technique or the algorithm of bubble sort. Alright, so these are the 3 very important basic sorting algorithms that we have studied. Please take random examples or create examples on your own and try to apply these techniques to find out whether you are able to sort them or not. Alright, so with this I would like to wind up for today. Thank you.